So in the previous section we saw the basics of electro-pneumatic circuits, and we also saw how a relay works, right? And the last thing that we saw was the latching circuit. Now you should always remember that in any electro-pneumatic circuit or any electro-hydraulic circuit, or for that matter even in any PLC diagram, ladder diagram, the latching circuit is the first circuit that needs to be drawn, right? So latching circuit is very important for your syllabus. Now having said that, I will now start off with in last lecture we saw a plus a minus motion. That is, we saw the motion of circuits having only one cylinder. In today's session we will be seeing the circuits of circuits which have two cylinders, right? So when I say circuits have two cylinders, what do I mean? See, this is one cylinder and this is another cylinder, right? So always in exam, see, they will give you what a plus a minus b plus b minus kind of motions. So there is one cylinder, let this cylinder be a, and there will be another cylinder, let this cylinder be b. So there will always be two cylinders and you have to control the motion of both these cylinders. Now how this motion will take place will be given in the question, right? So right now we will call this cylinder A, and similarly we will call this other one cylinder B, right? Now let us say that they have given us a question of A plus B plus A minus B minus, right? The question that they have given us is A plus B plus A minus B minus, right? And we have to draw this circuit. Okay, this circuit is pretty easy, it is not that difficult to draw. But before explaining this, I won't explain to you the simple method in this. Okay, I will directly go to the latching circuit, right? Because as such in exam you always have to draw the circuit by using the latching, not always but generally it is always better. There is one single circuit which, if you remember now, you can draw any kind of circuit that comes in exam, right? So I will be directly explaining it to you using the latching plus the cascading method, right? This is what I will do to you directly. So latching plus cascading method will be taught to you, right? So whenever you are using cascading method, if you remember from your pure pneumatics sums, you will remember that when you have piston motions, for example, what can the piston motions be? Piston motion can be either a plus b plus, a minus b minus, or piston motion can be a plus b plus, b minus, a minus. Now these are the only motions which are given in your syllabus, right? So in this, how are you going to make groups? Remember, when you make a group, one alphabet can come only once in a group, right? So from here our group 1 will start. This will be group 1, right? In this group A comes once, B comes once. Now A is coming once again, so we cannot have A once again. So this is where our group 1 will end. This will be our group 2, right? So I will currently, okay, and for this also, see how will be the groups. This will be group 1, A comes once, B comes once, B is coming again, so this becomes your group 2, right? So this is how we are going to divide it into groups, right? In ladder logic, what did we do? In ladder logic we had limit switches, so we had higher limit switches and lower limit switches, right? Here what do? Here we assign a relay to each group. So this is my group 1, I will assign it a relay called relay 1. Here there is group 2, I will assign it a relay called relay 2. Okay, from now onwards I will be focusing only on this question. We will look at this question afterwards. Okay, so in A plus B plus A minus B minus question, there are two groups, group 1, group 2. Each group is given its own relay. So A plus B plus has its own relay, relay 1, and A minus B minus has its own relay 2. Then another important thing that we forgot to do, what was that? To write the sensors, right? Which sensor is affecting which motion. So A plus motion. How will we know that A plus motion is completed? When A1 sensor is sensed. Let us say there are four sensors, A0 A1 and B0 B1, right? So what does A0 do? A0 tells us that the piston is in completely inward position. A1 tells us that the piston is completely in forward position. B0 tells us that the piston is completely in inward position, retracted position. B1 tells us that the piston is in completely advanced position, forward position. Okay. So how will we know that A plus motion is completed? By A1 sensor. How will we know that B plus motion is completed? By B1 sensor. How will we know that A minus motion is completed? By A0 sensor. And how will we know that B minus motion is completed? By B0 sensor. Right? So these are the sensors. These are the groups that will be required. Right? So now this entire circuit, first I will show you using the simple method, and then I will tell you the bigger circuit which you have to remember. So if you remember from your previous sum that whenever we have to draw any electro-pneumatic circuit is divided into two parts. There is the pneumatic circuit and there is the electro part of the circuit, right? So this is what we have to do. So let us start with the pneumatic circuit. So remember, pneumatic circuit is very easy. For electro-pneumatic circuits, the pneumatic part of the circuit is very easy. So here we have to draw A plus B plus A minus B minus. So we will require two cylinders. So we have drawn two cylinders. Immediately after drawing two cylinders, what do we have to do? We have to control these double acting cylinders. So if it is a pneumatic circuit, we will use a 5/2 direction control valve. Right? So this is a 5/2 direction control valve. It will be what? Double solenoid operated. That is solenoid actuated, solenoid return. Right? Solenoid actuated, solenoid return. Right? So this part is done. Now next what do we have to do? We have to name these solenoids. So what will be the name of this solenoid? I have explained you the naming convention. Sorry, this will be Ka plus, and this will be Ka minus, this will be Kb plus, and this will be Kb minus. Okay. Another thing that we have to do is what? We have to position the sensors, right? We have to position the proximity sensors. So there will be proximity sensors over here, right? It will be A0, which will sense that the piston is in completely retracted position, and A1, which will sense that the piston is completely in the advanced position. Similarly, we will have position sensors over here. Oh, sorry, I'm extremely sorry. Over here, I will have position sensors. It will be B0 and it will be B1. Right? So these are my position sensors. What do I have to do? I have to attach compressors and exhaust to the lower ports. So this will be my compressor. There will be another compressor. Okay, you can draw the same compressor and put it to two connections. I am just drawing two different compressors over here. Okay, you can draw as many compressors as you like. It just makes reading the diagram much more easier. Okay, so this part is done. See, the pneumatic part of the electro-pneumatic circuit is very simple. It will give you 2 marks directly. Okay, see, it is so simple, it will always remain the same. Now whatever be the motion, whether it is A plus A minus B plus B minus or A plus B minus A minus, okay, whatever kind of motion it will be, the pneumatic circuit will always remain constant. It will never change. Okay, so this is what we shall be, this is what we have drawn. So with this we complete the pneumatic circuit. Now we have to draw the electro circuit of the electro-pneumatic. So how to start with the electro circuit? I told you the first circuit in each and every the first line in each and every circuit should be your latching circuit, right? So first of all, to draw the electro circuit, we need a positive voltage, we need a ground voltage which is 0 volt. First circuit is your latching circuit. So to draw the latching circuit, what do we require? We require a NO push button, we require a NC push button, and we require a relay. Right? These are the three things that we require. Additionally, we require a NO connection of the relay. So all these things are over here. I will connect these things. So this is the relay circuit that we have drawn. This is the latching circuit that we have drawn in the last lecture also. Right? You must know this by now. So this is my start. This is my stop. Right? This part is done. Now this will start my entire circuit. This will start my entire circuit. Now, next part. See, what did I teach you? What did I tell you? That each group has its own relay. Right? Each group has its own relay. So how many groups do we have? We have two groups, G1 and G2. So how many relays do we have? We have two relays, relay 1 and relay 2. So each group has its own relay. So how to draw the circuit? See, I won't go into extreme depth when explaining this. I will go to a basic kind of a depth. So please try to stay with me. Okay. So see, what should happen? See, whenever my circuit starts, what starts? Relay 0 starts. And whenever I want to stop the circuit, relay 0 stops. Right? So when I start, relay 0 starts. When I push stop, relay 0 stops. So basically it is relay 0 which is controlling when my circuit is on and when my circuit is off. Right? It is relay 0 which is actually controlling when the circuit is on and when the circuit is off. So what we are going to do, we are going to make sure that each and every connection goes through relay 0. That each and every connection goes through relay 0. Why? So whenever relay 0 gets turned off, the entire system will get turned off. So electricity will go to the entire circuit through this position. So as long as relay 0 is closed, only then the entire circuit will work. If the relay 0 opens, the entire circuit will fail. Means not fail, stop. Right? So what is the first motion that should happen? The first motion that should happen is A plus. For A plus to happen, which wall solenoid should be activated? Ka plus wall solenoid should be activated. Ka plus wall solenoid actuation will give me A plus motion. So I require a wall solenoid. Okay, so I will draw the wall solenoid Ka plus. Right? Now, when should Ka plus be activated? See, you have to understand, for Ka plus to activated, which sensor should be sensed? B0 sensor should be sensed. So when B0 sensor is sensed, Ka plus should get activated. So what I will do, I will put a NO of B0 over here. I will put a NO of B0 sensor over here. So when B0 sensor is sensed, it will send electricity to Ka plus. But when B0 sensor is not sensed, it will not send electricity to Ka plus. But at the same time, there is additional one thing also. See, what did I tell you? That each group has its own relay. So here which relay is there? R1. So for group 1 to stay active, which relay should be active? Relay 1. So group 1 should only work when relay 1 is active. Right? So what I will do over here, I will use another NO switch and this will be R1. Right? So this will be R0 to R1, R1 to B0, B0 to Ka plus. Right? What this circuit is telling me, that when should Ka plus get activated? When Ka plus gets activated, what is going to happen? A plus motion is going to happen. For A plus motion to happen, what all things should happen? For A plus motion to happen, first of all, relay 1 should be active. Relay 1 shows that group 1 is active. And at the same time, what should happen? B0 sensor should also be sensed. Only then A plus motion will take place. Thus for Ka plus to happen, both R1 should be sensed, that is R1 should be on and B0 should be sensed. That is why over here for Ka plus I am putting R1 also and B0 also, right? Next motion is what? Next motion is B plus. For B plus to happen, B plus is in which group? Group number 1. So it will be actuated by relay 1. And which sensor should be sensed for B plus? The sensor sensed for B plus is A1, right? So for B plus to happen, two things should be on, R1 and A1. So that is what I will draw over here. For B plus to happen, I need two sensors. So two switches, R1 and A1. So when R1 and A1 are active, what motion will happen? B plus motion will happen. So it will be KB plus, right? After this, right, I will connect this over here, I will connect this over here. Why? Because when R0 is not sensed, all the motion should stop, right? So that is why all the electricity will flow only through R0, right? Next, what is the motion? The next motion is A minus. When should A minus takes place? A minus should take place when relay 2 is active and when B1 is sensed. So for A minus to take place, what are the two things that should be on? R2 and B1. So over here, the same circuit will be copied over here. The difference will be, this will be R2, this will be B1, and this will be Ka minus, right? This will be connected over here, this will be connected over here. And then what should be the last motion that should happen? The last motion that is happening is B minus. B minus is part of which group? It is part of R2. And which sensor should be sensed for B minus? A0. So for B minus to happen, R2 and A0 should be on. So over here R2 is correct, over here we need A0, right? Then Ka minus will be active. It will be Kb minus. See, last motion is B minus, so it is Kb minus, right? So this is how the entire circuit will look. Now over here you can see, let's see, over here also we have R1, over here also we have R1, here we have R2, here also we have R2. So rather than drawing R1 two times and R2 two times, what we can do, we can directly delete this, right? Just a minute. And we can connect this over here. See, this is the same thing now. Rather than drawing it two times, we can draw the remaining circuit in series after this R2, right? So a similar thing I have done over here with R1, and that is what I am going to do with R2 also over here, right? So this is how the circuit can be drawn easily, right? So electricity will go through R0. If this entire circuit is not on, then what will happen? R0 will not have electricity. If R0 does not have electricity, nothing will work. But if R0 has electricity, it will move forward. If R1 is sensed, that means first group is active. If first group is active, then what will happen? If piston B is in internal position, completely inside, electricity will go to Ka plus. Because of that, A plus motion will happen. When A plus motion completes, A1 sensor will be sensed. When A1 sensor is sensed, Kb plus motion will happen. When Kb plus motion happens, then R2 should be activated. Then B1 should happen. Then Ka minus. Then all this will happen. Right? Right? So we have drawn the basic circuit. But what is the main problem with this circuit? See, even if I start this, R0 is started. Neither R1 nor R2 is active. Right? Neither R1 nor R2 is active. But R1 and R2 should become active. So how can I turn on R1? Right? I have to turn on R1 some way. Okay. So what ideally I should do, I should move all this towards right, and I should draw the R1 circuit over here. Okay. So you can do it like that also, or you can draw the circuit at the end. It is completely up to you. It doesn't matter. But right now I will draw the circuit over here just for understanding's sake. It does not matter. Okay, I will let it be over here only. and I will draw the R1 circuit at the end. Okay, it doesn't matter at all, right? So when should R1 turn on? See, R1 is the first group. R1 is the first group. So as soon as I push the start button, R1 should get on, right? As soon as I push the start button, R1 should get on. So for that, what do I have to do? I have to put R1's coil. See, R1 is a relay. To turn on the relay, we have to turn on the coil. So what I will do, I will put R1's coil over here, and I will take a duplicate start switch and put it over here. So whenever the start switch is pushed, what will happen? Immediately R1 will get activated, right? R1 will get activated because of the start switch, right? When should R2 get activated? R2 should get activated when the group 2 starts. When does the group 2 start? The group 2 starts when B1 sensor is sensed. So group 2, that is same as relay 2. Relay 2 starts when B1 sensor is sensed, right? So over here, what I will do, I will just move this towards the, sorry, just a minute, right? Okay, so when should R2 say R2 coil be started? When B1 sensor is sensed. So similar to this, what will I draw over here? I will draw over here that when B1 sensor is sensed, R2 coil should get activated, right? When B1 sensor is sensed, R2 coil should get activated, right? Now this circuit will work. There is still a problem with this circuit, but see what happens. I turn it on. I will just zoom out a little bit so that we can see. Now this circuit will work, but after some time it will stop. Just see, simulation is slow. Okay, I start it. I will just pause it. Okay, see what is happening. As soon as I press the start button, electricity goes through R0 coil. Because of that, see, these two R0 switches will close. This will become FC. Now see, immediately electricity went to what? Electricity went to R1, right? Because start button is pushed, electricity went to R1, right? R1 got electricity, so this R1 will also close, right? See, this R1 over here will close. This R1 closed, Ka plus got electricity. As soon as Ka plus got electricity, now Ka plus will get electricity, so this position of the valve will get active, right? This position of the valve got active, so compressed air is going to the left side. Compressed air is going to left side, piston is moving forward. Piston moved forward, reached A1, right? But what is happening? See, even after this, now it is not moving forward. Why is it not moving forward? Because R1 got deactivated. R1 got deactivated. So what do I have to do? I have to put a circuit which will keep R1 on. Which will keep R1 on for certain amount of time, right? So what is that? A circuit which is used to keep a circuit on is similar to your latching circuit, right? So over here, what I will do, I will say, just like here, R0 is kept latched on by what? R0's NO. Similarly, I will use a NO of R1 to keep this circuit on. I will use a circuit to keep this circuit on continuously, right? So this will be continuously on. It will keep on getting electricity. Now again this will cause a problem. We will see, because it will remain on continuously for a very long time, right? Sometimes at some point it should stop. No, we will come to see what that point is, but right now let this be. Okay, so we start this. Again we press the start button. Okay, I will just pause it, bring it back. I press the start button. Electricity reached R0. R0 will get active. electricity reached R1. See, R1 is now closed, R1 is now latched also, right? So piston A will move forward. It will reach A1. See, as soon as it reached A1, electricity will reach KB plus. Piston B shall start moving forward. Piston B is moving forward. It reached B1, right? It has reached B1. B1 has done what? B1 has activated R2. See over here. B1 has activated R2. R2 over here. So see, R2 will get activated. R2 got activated. B1 sensor is sensed. What is going to happen? Ka minus is going to happen. So piston A shall start moving backwards. Piston A reached extreme end position. Now see, Kb minus will get active. Now the problem, okay, Kb minus got active. So Kb minus is getting electricity. Now what will happen? The piston shall move backwards. Right? So this is what is happening. Now in this, see, if I run it, you will see that this R1 is continuously on. Right? R1 is continuously on and R2 is not continuously on. R2 becomes on for a very small amount of time. R2 becomes on for a very small amount of time only when the B1 sensor is sensed. This is now how it should be. R2 sensor should also have its own latching circuit, right? R2 sensor should also have its own latching circuit. So over here we will give R2 its own latching circuit, right? Now there is something known as mutual exclusivity, right? Now what do I mean by mutual exclusivity? Now see, by now you should have realized one point. Let's see, when relay 1 is on, over here see, when group 1 is on, group 2 should be off, and when group 2 is on, group 1 should be off, right? At any given time, only one group should be on. We saw that in our pure pneumatic circuits also, electro-pneumatics also, at any given time, only one group should be on, right? So over here, what do we have to do? We have to ensure that when group 1 is on, group 2 remains off. And when group 2 becomes on, group 1 becomes off. So to do that, what do? We put a NC over here, right? We will put a NC over here, not a NO. We will put a NC over here. And this NC will be of R2. So see, what is going to happen when R2 turns on? It will make this circuit functionally open. Because of that, R1 will turn off. And when R1 turns on, I will put a similar NC circuit over here. It will be R1. When R1 turns on, it will cause R2 to turn off. See, what do I mean by that? Okay, just a mistake over here. Some problem over here, I don't know. Right, okay, right. Now see, what is going to happen when I push start? See, as soon as R2 turns off, see, R1 will turn off, right? See, I will show you, right? The basic motions are happening. Okay, I will push the start button, right? See, R1 is now on, right? R1 is currently on. Now see, R2 is now getting electricity, right? So what is going to happen? The NO of R2 is going to become FC and the NC of R2 is going to become FO. As soon as it becomes FO, R1 will stop getting electricity. See, R1 stopped getting electricity. So now only R2 is active. R1 will stop and only R2 is active, right? Now, but because of this mutual exclusivity, see, there is one more problem because of this mutual exclusivity. A plus, B plus, A minus, B minus. Now the motion stops. After the B minus motion is completed, again A plus motion should happen. So see, over here, what did we do? Over here, What did we say? That when does group 2 become active? Group 2 becomes active when B1 sensor is sensed. Similarly, when does group 1 become active? No doubt it becomes active when the original start push button is pressed, but it also becomes active when the B0 sensor is sensed, right? So to include that, there is another thing that we have to do, which I will just move it over here, sorry, and over here we will put another switch, another inner contact of your B0, right? Now this will complete your entire circuit. Now if you operate this, so it will be A plus, B plus, A minus, B minus. Immediately B0 will get activated R1, and this circuit will now work continuously without stopping until and unless I press stop, right? Stopped at this position, right? It will again start, right? So this is how this system will work, right? Now there is just one change that I want to tell you, that now in these circuits do not turn these solenoids on directly. To turn on these solenoids we should use relays, right? So rather than doing Ka plus over here, Kb plus over here, what I am going to do, I am going to use relays over here. Okay, see, this is not necessary, it works like that also, but just to make this the different types of sums that we are going to solve easier, I am suggesting you to do this, right? So over here it will be Rb plus, we haven't made these relays yet, these are just the coils. This will be Ra minus, this will be Rb minus. Okay, see, there are reasons, like I told you, I won't go into extreme depths to explain you why this, but this makes the circuit much more easier. So this is the entire circuit that you have to remember. This is Ra minus, this is Rb minus, right? And over here these solenoids are, see, now if I start the circuit, I start this, nothing is going to happen because Ka plus Ka minus, Kb plus Kb minus are never turned on and turned off, right? To turn them on and off we are going to use these relays, right? So we draw another circuit over here. See, this is known as the control circuit. This circuit is known, this electro circuit is known as the control circuit. Similarly, we will draw another circuit over here which is called as the functional circuit, right? We will draw another circuit over here which is known as the functional circuit, and the functional circuit is same for all, each and every sum, each and every sum in the your syllabus has the same functional circuit. Just as each and every electro-pneumatic circuit has the pneumatic part same, similarly each and every functional circuit is same. Okay, so we have these four. This is Ra plus. So whenever Ra plus is activated, what should happen? Ka plus should get activated. Whenever Rb plus is activated, Kb plus should get activated. Whenever Ra minus is activated, Ka minus should get activated. And whenever Rb minus is activated, Kb minus should get activated. Right? I will just showing this, this over here, this over here, this over here, right? You can draw this part at the end of this also. You can draw this over here also, that is also perfectly acceptable, but I like to keep these two circuits apart because this circuit is never going to change. Whatever the question might be, this circuit is never going to change. Sorry, this circuit is never going to change. The only thing that is ever going to change is your control circuit, right? This is the only thing that is going to ever change, right? So this is the only thing that we have to make a little bit of changes as per the question requirements, right? So now see, if I turn this on, start, a plus, b plus, a minus, b minus, right? In the previous questions, what were we doing? In the previous method, what were we doing? We had put ka plus, kb plus, ka minus, kb minus over here. Instead of that, we have put relays over here. So when this becomes, see, relay A got activated, so Ka plus got activated. Relay B got activated, Kb got activated. Relay A minus, Ka minus. Relay B minus, Kb minus. So each relay is turning on its own valve solenoid, right? So this is the circuit. So in exam, if you ask the question to draw the electro-pneumatic circuit for A plus B plus A minus B minus, this is the circuit that you should draw, right? Now, at the same time, now that you have understood this circuit, hopefully you have understood. Even if you haven't understood, you can always mug it up, right? As I told you, I am not going to go in extreme depth. This part should be understood by you right now, okay? I will just go through it over once again afterwards, but just I will show you why I focus on this circuit. See, there are several thousand different circuits that you can draw to achieve this motion, each more or less complicated than each other. Okay, you can make the circuit as complicated as you like, you can make the circuit as easy as you like, but I want you to remember this circuit because this circuit can be used for any kind of motion given in any syllabus in your exam, right? For example, say if they want me to draw A plus B plus B minus A minus, right? The next motion that they want me to draw is A plus B plus B minus A minus. The only thing that changes is, see, how will I know A plus is completed? A1 will sense, B plus B1, B minus B0, A minus A0, right? Each sensor tells us that this motion is completed, right? So see, what are the changes that are happening over here? B0 got changed with what? A0, A1 is same, B1 is same, A plus is same, B plus is same, A minus got changed with B minus, and B minus got changed with A minus. And what happened? A0 and B0 got changed. So basically A minus B minus got changed and A0 B0 got changed. So all you have to do in this circuit also is the same. A minus B minus changed. So over here I will put RB minus. Over here I will put RA minus. So I basically changed just the A minus and B minus. And what other things I have to change? I have to change A0 and B0. So wherever there is B0, I will put A0. Here also there is B0, I will put A0. And over here there is A0, I will put B0. Now just by making these changes, see, if I push start, A plus, B plus, B minus, A minus, right? Only thing I changed is the positions of the relays and the switches, right? This is why this circuit is so important. Only changes you had to make were these, right? Over here, and over here, right? So this is how I can draw the circuit for A plus B plus A minus B minus, or A plus B plus B minus A minus. Now in exam sometimes if you see, okay, I will just show you the exam questions, right? So in exam sometimes they tell you that there is a delay. Not only a delay, but see, AB minus, right? A and B are taking place together. AB minus is taking place together, and sometimes there can be a delay, right? first I will look at this delay part, then this together motion part. Okay, this question is paper is not extremely clear. I will go to this question paper. See over here what they have told us. First is delay, then A plus, then B plus, then AB minus together, right? So how to add this delay portion? Okay, to add this delay portion is very easy. Where is the delay? Delay is before A plus, right? It is before A plus. So what do? We have to change the relay A plus. Because the delay is before A plus, we have to change the relay A plus. Rather than putting a relay A plus over here, we are going to use a relay with delay. Okay, we are going to use a relay with delay. So what exactly is a relay with delay? See over here. See, this is basically a relay with delay. So what does this relay do? This relay, after the relay turns on, it does not turn on its NO switch or it does not turn off its NC switch. It waits for a specific amount of time. Over here see 5 seconds. Right now I will just put it equal to say 0.5 seconds because I slow down the animation. Right, I'll just put it 0.3, so it will be okay 0.5, so it will be off for 5 seconds. So it will keep the circuit delayed. It will put a break in between, right? So rather than drawing that symbol, you have to draw this symbol. See, just the symbol is different, nothing is different. Now this might give you idea why I am using a relays over here, right? Why I just started using relays over here instead of directly putting those solenoid valves. So this makes the circuit, drawing of the circuit, much more easier, right? So now see, where did I put the relay with delay? Before the motion. See over here, where did we require the motion? We required the delay before the A plus motion. So I put the delay before A plus, right? So I put the delay before A plus, RA plus. Now see, if I turn it on, see start, what is going to happen? Just a minute, something went, okay, right, because the A plus motion, there is a delay, na? See, so even when I push start, the motion did not start, so it is counting down. After 5 seconds, A plus, B plus, B minus, A minus. Now see, again relay A will counting down 5 seconds. Again A plus, B plus, B minus, A minus, right? Again count down 5 seconds. So this is how we can put in delay, right? And now for AB minus, for together motion. See, for together motion, what do you have to do? For together motion, see, basically what is together motion? See, to understand this concept of together motion, see, in this case, when A plus, B plus, A minus, B minus, when these motions were separate, so for B plus to start, A1 sensor needed to be sensed. For A minus to start, B1 sensor needed to be sensed. For B minus to start, A0 sensor needed to be sensed. And for A plus to again start, B0 sensor need to be sensed, right? But here what they have given us, A plus is a motion, B plus is a motion, and AB minus is a single motion. So for B plus to start, A1 should be sensed. For AB minus to start, B1 should be sensed. And for A plus to start, it is not a single motion now. For A plus to start, two things must be sensed. A0 must also be sensed and B0 must also be sensed, right? So here also A0 and B0, right? So these are the things which we will put over here. So over here, what is the thing that has changed? See, for A plus, there are two, A0 and B0. So for A plus, there are two. There is not A0 only, but there is also B0. that both A0 and B0 should be sensed, only then RA plus should take place. I am removing the delay part right now, I will put it in afterwards, right? Then after A plus is completed, A1 will be sensed, RB plus will happen. After RB plus happens, B1 will be sensed. But here, after B1 is sensed, both A minus and B minus should happen. Both motion should happen. So what will I do? Rather than putting, see here what is happening, first B minus is happening. After B minus is completed, A minus is happening. But that should not happen. Now B minus and A minus should happen simultaneously. So I will connect it like this, right? Now so basically what did I do? I replaced A0 by A0 B0, right? I replaced A0 by A0 B0. So over here also, when should R1 start? R1 should not start when only A0 is sensed. R1 should start when both A0 and B0 are sensed, right? So this becomes my circuit, right? So see, over here what will happen when I push start button? A plus, B plus, and both will move backwards simultaneously, right? And now if I want a delay, let us say that I want a delay before B plus, okay? If I want a delay before B plus, what do I have to do? I have to delete this relay over here, put in a relay with delay over here. You have to write 5 only in your exam. I am writing 0.5 just because I don't want it to be too long, otherwise it will wait for 50 seconds because I am slowing it down by a factor of 10. Okay, so now see, start, A plus happens. Now see, it is counting down for 5 seconds. B plus will happen. Now AB minus will happen together. Again A plus, 5-second delay, B plus and AB minus together, right? So this is how the circuit can be drawn, right? So I am telling you again and again, this circuit is very easy. Only changes have to made in these few connections. There are 4 or 5 connections that change in the entire circuit, right? I will just draw the original basic circuit over here. I am drawing the original basic circuit over here, right? There is one over here, there is one over here, delete this, C Ctrl V. Okay, so let us draw for A plus B plus, A minus B minus. So because it is A minus B minus, this will be B0, this will be A1, this will be B1, A plus B plus, A minus B minus, na? So it will be RA minus, it will be A0, it will be RB minus, right? And over here also it will be only B0, sorry, it will be only B0, and here it will be B1, right? So this is how, this is your basic circuit. This is what? A plus B plus, A minus B minus. Now imagine you want that there should be a delay before A minus. What to do? Find RA minus, replace RA minus with relay with delay. So delete this, put this over here, this becomes your RA minus, and I will run the circuit. So what will happen? Before A minus there will be a delay. Okay, there is a delay, both are happening together, both are happening one after the other. Okay, now what if I want A plus B plus motion to happen simultaneously? Okay, that is what I want the motion like this: A B plus delay A minus B minus. So I want AB to take place simultaneously. For AB to take place simultaneously, what is the input that is required? B0. For A minus to happen, what are the inputs required? A1 and B1. Right? So I will make the changes over here. For A minus to happen, I require two things. I require A1 also and B1 also. Copy paste, delete this, put this over here, connect, connect. Okay, this is sensed. A minus will happen, then B minus will happen over here, B0, and both should happen simultaneously. So no need for this. We'll connect this directly over here. So this will give you AB together plus, then delay, then A minus B minus. Right? See, AB both moving forward, then 5-second delay, A minus, and then you will have B minus. See, that is why this is what I am telling you again and again, that remember this basic circuit. Okay, if you remember this basic circuit, your life will be very easy, because this you can draw any circuit in your exam using this basic circuit and making a few changes to it as required. So see over here in your exam, the pneumatic part and the operational circuit will remain the same. It will never change. The only thing that is going to change is your control circuit. In your control circuit also, the latching is not going to change. Much of this part is not going to change. Just the sensors which are connected, these are going to change, and the position of these relays, and whether they are pure relays or whether they are relays with delays. These are the only things that are going to change in your circuit. So hopefully you have understood the electro-pneumatic circuits. I will take a lecture on this also again, just to explain this to you completely, and then I will teach you how to change a pneumatic circuit into a hydraulic circuit. Okay, so thank you.